Hello, everyone. In this video, I would like to talk about the method of completing square using some area model in Polypad. Before we start, you may have a check of the tools available in Polypad. Right? There are some algebra tiles which can be very useful in discussions about algebra. But in this examples, I would like to use the geometric shapes. Okay? So you can find it in the geometry panel. So here we'll get some rectangle to make some tiles to represent algebraic expressions. And to do a setup here, I will open the grid, okay, and get a square like this. We'll use it to represent x squared. And here is another tile. You can make it any rectangle you like, okay, but have the same length as the other one. And so the width can be anything. It's just used to represent another terms, b times x, for example. Okay, now we can take away the grid, okay, and concentrate on these two tiles. And I would like to use some segment to mark the length, okay? And here in the line segment 2, I turn it into black again. And I would like to add this one segment to represent the length of the square, and also the length, another length of the another tile. Okay, down here, we also emphasize that it is the same length, right? Now we go to the labels, right? And you can use the mathematics expression tool here to input any labels, right, for the length. And you can duplicate, copy it here, and then show it on the other side. Okay, for this length here, for the green one, we may use the term B, okay, to represent it. So that now you can talk about the area. So in terms of the area, the x here, the square term, right? We have x squared. You can make it bigger. Okay, similarly, for the green tile, okay, it will be b times x. Okay, so you can put it here and make it also bigger. I think it's more or less the same. Okay, right. That means this can also represent as a whole the expressions x squared plus bx. Now we're going to rearrange it so that it will make almost a square, okay? And to show how you can express the terms, this area in different ways, okay? And before we do that, we'll everything and try to compare later on. Okay, so I have a set, another set, which is the same, x squared plus bx. But very soon I would like to transform it. Okay, so we arrange the green tile, okay, into two parts. Okay, I need to actually bisect the green tile. Okay, so I can do it here more accurately using the construction tool, perpendicular bisector of this length segment. I highlight this one and add the perpendicular bisector. Okay, and with it, I can divide the green piece into two parts. Now, basically, you can now go to the highlight, click the green tile, and then because it's a polygon in Polypad, you can do any cutting. Okay, so you can choose the cut option. I can demonstrate briefly what does it mean. You can draw any line anywhere and then divide, okay, cut the piece into two parts and then manipulate separately, okay? But of course, for our algebraic manipulations, we would like to divide it along this line, okay, the perpendicular bisector into two equal halves. So this time I click the green part again and then do the cutting, click the cut. But now I try to, oh, sorry, maybe I use, okay, cut. And maybe I have to do it again. All right, so now I can use slowly drag along this vertical line, all right, so that I make sure the cut is vertically in the middle. Okay, and now I release it. All right, let's see. Yes, so we have split the green tiles into two equal parts, right? Two rectangles. Okay, maybe now you don't need the perpendicular bisector. You can delete it or hide it. Okay, and now I choose to delete it. So, and therefore, this length, the remaining part will be b over 2. And the term here will be b over 2x. And this should be the same, right? But now I would like to rotate it and put it under the square, right? And which should be the same area and the same length as well on the other side. Okay, so this will look closer to a square, right? That's which we may want. Okay, and in order to highlight what do we mean by square, you can use another construction tool, a rectangle. So down here, somewhere, start anywhere you like, and then try to drag diagonally. And also, okay, here, go back to the move tool, and then you can adjust this vertex, right? So that you will see there's a square enclosing the 3 tiles. But of course, we have a missing part, right, on the top, on the bottom right. Okay, but we can talk about the size of this big square, okay, which is x plus b over 2 whole square. So in order to complete it, and you will need another tile. I just use this rectangle tiles again. Maybe I turn it into orange one, okay, and then put it here and adjust it, okay, then it will fit inside. So how big is this square? Right? How should it be? What should it be? And so based on the length b over 2 and b over 2, we know the area here is b over 2, or the square of b over 2. I have to change the color again. So turn it into black, okay. Now I can type here inside. Okay, so it is the square of b over 2, right? So you can fit it inside to make a big square, or remind you that this is the one to be added, okay? And so the whole thing here will be the black square. We see the frame that we see, will be x plus b over 2 whole square, okay? Except that we don't have this piece, okay? So I can make it bigger. Okay, now, so that means we can say that the whole thing, right, this color part is this square minus this square, all right? So maybe we can use a pen to show that this part is being removed, okay? Therefore, the whole thing, the color one, to compare with the one above, it should be now, okay, this big square minus the small square, right? So this is what we do algebraically in completing square, okay? And that is the major demonstration I want to share with you here. Some minor modification that you may like, just let you know that you can choose to start with some number instead of a constant, okay, or some variable. Okay, so you can take b equal to 5 and then, or maybe adjust this label accordingly. Right. In fact, you can also add a slider, so you can see the algebraic side here. We have okay, variable slider. So since we use b, so maybe we can use the b to remind us, okay, the value of b can be changed. Okay. Now actually, if you look at the small number here, right, b, under b, you can see the value and the change of the value, right, when I drag the slider, okay? And similarly, you can also see b over 2 is 1.5, and so b over 2 squared is 2.25, right? And in fact, you can also directly plot these values. Maybe I now turn off the size. Okay, but I need tables, perhaps. Yeah, so you can get a graph or table, and then with this parameter b, and also link up these expressions with the graph here. Okay, now it may not really look right because this is not the parabola, of course, we want. Now the problem is that we don't have the multiplication sign included. So in fact, we should write this way with a bracket, then they will recognize it. So now it's x squared plus 3x, okay? And you can change it to see how it varies. And similarly, for this one, you can also, okay, plot it here. But of course, you won't see the difference, right? Unless, and you may change the color, turn it into a red one, then you can see that it is another graph, overlap it, okay? Or you can also perhaps take away this small square. And let's know that the bigger square is actually, okay, an expression bigger than this one, okay, by a constant. That's why the graph is like this, okay? And you can still vary the b and then try to compare, or even when b is negative, right? And you can see the values is here. In fact, it represents the difference between the vertices of the two parabola. Okay, so these are additional manipulation that you would try by using graph, but I think the main point here is using the area model, right, to demonstrate the meaning of the process of completing square. Okay, so go ahead to further explore the use of Polypad, okay, which allows you to make use of different kind of representation at the same time, and also manipulation. And finally, if you have an account in Polypad, okay, you can log in and then draw this file and then save it. Okay, so you can make it, let's say, I have another files already, so I name it as complete square 2. Okay, and then save it. Okay, and it will be stored under my account. Okay, so this is the file. Okay. All right. Let me see. Right, so I think this is the end of the demonstration for this video. Okay, thanks for watching.